My name is Roger Singleton. I'm the owner of Silt-Saver. I'm here today with Tim Goff, our operations manager, and we're going to do some tests to dispel an old belief that wire-supported silt fence is stronger than wood post and new technology. In our efforts to bring better performing products to the sediment control industry, we're often roadblocked by old material specifications. Some of these material specifications has been in our state manuals for over 30 years. At the time they were written, it was believed to be the best design available. However, it was never tested as a system. Silt fence consists of several components, one of which is the fabric, which is often tested, and the structural element is never tested. Structural system of steel posts and wires used with silt fence is one of these specifications. This system is relied upon in many states as the best BMP for protection of their wetlands and waterways. The fabric used for this BMP has been tested for years, but the structural component for this system has not. Today we will simulate the horizontal load of mud and water utilizing vertical loading. The test will be applied to a steel post and wire supported specification drawn from the Tennessee DOT EC STR3C. The Silt-Saver belted retention fence and the Silt-Saver stage release silt fence will also be tested. Both the BSRF and the SRSF fabrics are proprietary products of Silt-Saver Incorporated. Each of these systems utilize wood post and no wire. Today we're going to use this apparatus that we built in order to test our own post and our own method of attachment under sediment loads. There's a channel in the front that the post just slides down in, and eventually we'll turn this over so that we can load it horizontally. In order to make the test equal, we're going to take a steel post and cut it down to 4 foot in order that it can be tested equally with a wood post. We're going to have 26 inches of fabric above ground, 8 inches into the trench, and 14 inches driven into the hard pan, with the assumption that both steel post and wood post are installed correctly with the ditch compacted. Now this test is above ground testing to see if the silt fence that stands above ground for either system can hold the load of sediment that it's required to do. We're going to get started with the wire now. It's going to be our first test. We're back now. We've got the wire installed on the vertical post. Again, we use the 1 1/4 pound post. It's got the knobs on it to hold the wire. The specification calls for 5 ties. We've got 1, 2, 3, 4, 5 ties on it on both sides. We're utilizing a farm fence number 832-6-12 is the specification for the wire itself. All right, we're back now and we're going to show you the fabric. This is about a 250 pound monofilament fabric. It's placed onto the wire with hog rings every 2 foot and also one in the center every 2 foot. And I think that pretty well follows the specifications of the system of the ECSTR3C. Now, as you can see, this system is a multi-component system. Failure of any one of these components is a failure of the total system. We've tested the fabric, but we've never tested the structural element of the fence. We're going to take this same apparatus now, we're going to turn it around, and we're going to flip it over so that we can load it horizontally. We'll measure to the center of the fabric. We'll put a piece of tape on the center so that we know we're loading the bags of cement equally. That's 24 inches. All right, we're going to start loading the bags, and we're going to load 100 pounds at a time until we get to a point where we think we won't carry 100. We'll load from both sides. That's 100. 200. $300. $400. If you notice the post on that side, it's already bending. Now, these posts were designed to hold up wire for cattle fence, not to hold up loads of sediment. We're going to try another 50 pounds on that. It's falling in at 450 pounds. There's 4 bags still on the fence itself. There's 5 bags on the floor. We had failure at 450 pounds. I've asked a lot of engineers, what's the horizontal load of mud and water? They can't tell me. I've asked a lot of people about the results of testing for this method of attachment. There has been no testing, so therefore there's no results. But we still rely upon it as our strongest method in the field. Maybe this test can clear up some of those misconceptions. Thank you. As we said earlier, this apparatus is a product of evolution, and it's a multi-component system where you had the post, the wire ties, and the fabric, and the hog rings, where any component failure would constitute a failure of the total system. What we've had here is as the load loaded up between the post, it actually bent the post. You can probably see that pretty good as to what happened to the post. Now as we go forward and we compare the other two systems, we're going to be comparing wood post, same spacing, with fabric of new technology that lets us eliminate all of this apparatus here with the expense of the wire.